Machine learning has become a driving force across various industries, revolutionizing the way we analyze data and make our decisions. Over these last few episodes, I've broken down machine learning into sizable chunks to help you learn faster. Today is no different, but today we're taking the next step in our adventure, and we're going to learn how you can choose the right machine learning model for your needs. Welcome back, guys, to another episode of PyPod Chronicles. Before I dive into today's episode, guys, I'm stoked to have you here. Do me a favor, hit the like button on whatever platform you're listening on, as that helps me grow my podcast, alright? All my resources I have, they're all free, okay? It's the link in the description of the podcast. Head over to the blog, all the advanced stuff is there, and you can get a 13-hour Python course if you're a beginner. It's absolutely free, okay? It's my course, it's over there. So head on over, check it out. I have guides for you guys, you name it, it's there for you. Use it. That brings us back in today's topic of how we can choose the right machine learning model. And in the vast landscape of machine learning, understanding these nuances of classification or regression and clustering is crucial. Are any of those words new to you? Well, that's what we're going to talk about. These three pillars form the backbone of machine learning applications, and they each serve a distinct purpose in making sense of our data. ML, simply put, allows computers to learn patterns and make decisions without explicit programming. Its applications range from, predicting stock, right, all the way to healthcare in diagnosing different diseases, right? That's incredible. Right? If you think about it, 15 years ago, where the hell were we? Nowhere close to this. This is incredible. The three pillars of machine learning. So imagine machine learning as a three-legged stool, with each leg representing a different path we could take with our models we create, like classification, regression, or clustering. For the stool to stand sturdy, each leg must be understood and utilized correctly. That's where we come in. That's where I come in to teach you, and that's where you come in to use it effectively, right? It's taken me a while to grasp these topics, and I'm still learning every day, okay? But hopefully this will help you learn faster than I did. Let's begin with classification. So imagine you're a librarian. Your sole purpose is organizing an extensive collection of books. Now, each book is a data point, and your task is to classify them into distinct genres. That's how a library works, okay? This mirrors the essence of classification in machine learning, where the algorithm that we create learns to assign predefined labels to data based on the features we give it. Think of like email filtering, right? We get so much shit in our inbox. It's gross. A classification algorithm we could use to tell the difference between spam and legitimate emails, because it learns from historical data in our inbox. This allows us to identify patterns like specific keywords or sender addresses to make real-time predictions. Classification algorithms come in various types, like decision trees or vector machines or neural networks, okay? But just getting the overall idea down, that's key. That was classification. You're a librarian. Email filtering. Let's now talk about regression. So now I want you to picture you're a weather forecaster. I know, it's probably the most worthless job ever because they're always wrong, but just bear with it. You're a weather forecaster because we know they're always accurate, and you're predicting tomorrow's temperature. It's not about categorizing, but rather forecasting, guessing. A continuous value. This parallels the concept of regression in machine learning, where the algorithm predicts numerical outcomes based on current existing data. So a real-world scenario, regression models, not just the weather, which they do use them for, we could use it to predict stock prices by analyzing historical data, considering factors like market trends or company performance or even economic indicators. Regression models like this, like linear regression, polynomial regression, ridge regression, okay, there's a few others, okay, but that's not the topic of the episode. The episode is to get you involved with classification, regression, and that brings me to our final one of clustering. So speaking of clustering, this is when we group similar entities together. So let's transport ourselves to a bustling supermarket. Okay, so I live in Asia, And in Asia, the markets are quite different from first world countries where I grew up, like in America, like a Walmart, completely different, okay? So imagine you're in a bustling supermarket wherever you live, okay? And as a good shopper, you instinctively group together similar products. For example, if the toilet paper is on the left corner of the store and the seafood is on the right corner of the store, you're not going to go to seafood, then toilet paper, then back to meat, then back to clothes. That's a waste of your time. You do everything you need in a general area of the store and then you move on. Right? That's how clustering works. So this aligns perfectly with the essence of our clustering topic, where the algorithm identifies inherent structures within our data and then groups them accordingly. So in a scenario, right, imagine clustering could be employed to identify distinct groups of customers. So if I was a company, I would want to group together customers based on their purchasing behavior. This will allow me to tailor my marketing strategies to hit them differently, right? So there's different methods with this, okay? So we have k-means, we have hierarchical clustering, we have a DBSCAN, okay? There's a few different ones, but understanding the nature of data and selecting the appropriate algorithm, like I've been saying, is vital. Guys, I've been creating content for over a year now. If you want to show your support, right, head down to the link in the description and you can show your support as I grow even further in 2024. Now, moving on to how you choose the right machine learning approach. Well, selecting between classification, regression, and clustering depends on factors like the nature of the data and the problem at hand. So case studies can illuminate the decision-making process. So look at other people's case studies. What did they use and why? And assuming you've made it this far, you must have been asking the right questions, as that's important in this process. What outcome are you looking for? Think back to the last 3 models I've explained to you. Which one may be the one to help you make your prediction? I've been teaching for 7 years now. That's crazy. I've taught lectures with 60 high schoolers all the way down to private one-on-one classes. It doesn't matter our age. We all learn the same way as we did as kids. It's true. Not to bruise anyone's ego. Analogies serve as effective bridges, connecting abstract concepts to familiar scenarios. Imagine classification as a librarian, regression as a day trader, and clustering as an OCD person or an organizer. Now machine learning becomes more relatable. Okay, so I'll give you 3 more analogies and I'll let you on your way. Classification. The librarian's role mirrors classification because the librarian carefully organizes books into genres, and a classification algorithm deciphers patterns and assigns labels, just like a librarian relies on historical knowledge of genres and their experience to group the books. Regression. Our day trader, much like regression, navigates the unpredictable, volatile market conditions. Predicting future prices isn't about categories. It's about the forecast based on pre-existing data. Clustering. In the crazy supermarket, grouping similar items is the process we do as humans to shop faster. Just as we group together similar products, a business can group together customer data points as well. Alright guys, that was great. So some popular questions, right? The main difference between classification and regression is classification involves categorizing data into predefined classes, while regression predicts a continuous outcome. Clustering and classification is not different because clustering is when you group similar data points based on patterns, where classification is predefined patterns. Some common challenges that I face in regression is when I deal with outliers, so make sure you deal with outliers effectively. And one machine learning algorithm can be used for both classification and regression. So for example, like decision trees. I could apply a decision tree to both classification and regression. Wrapping up this episode, guys, that's the trifecta. If I have to say those words again, barnacles. Classification, regression, and clustering, right? That forms the backbone of machine learning. By starting to understand these concepts and their applications, you can unlock the true potential of machine learning in various domains. Start to look at your data and think of a few questions you could ask. Write down 5 questions as well as one of the models we've talked about in this article. Which ones could be used for what? Thank you guys for tuning in for another episode of PyPod Chronicles. I will see you guys next week. Until then.